All right. Can you guys hear me now?
Absolutely.
Okay.
Yeah.
Good. Good. I don't know what happened there, but that's good.
So Hannah, you can
Yep, started
introduce.
off.
Yeah.
All right, for sure. Well, hi everyone. Thank you for joining DataCon LA 2021. Welcome to the Intro to Data Science tutorial. I'm just going to hand this over to Zia, who's going to be leading the tutorial. So thank you for being here, Zia.
Thank you. Thank you for giving me the opportunity, guys. So let's get started. So my name is Zia. I actually work with the LearningFuze. So let me get started by first of all sharing my screen. So let's see how that goes. Live technology, that's the best thing in the world. So can you guys see the screen?
Yep.
Okay,
Yes.
awesome. Okay, good stuff. So, guys, I work with LearningFuze. I'm one of the data science instructors there at LearningFuze, and I've been in the field of data science for many years. And I just use many because if I use the actual number of years, then I look very old. So I leave it at many years. So the topic today that we are going to do today is we are going to actually do a hands-on workshop or hands-on data science tutorial. It will give you the opportunity to follow along, and it also you have the ability to actually ask any questions. So you are welcome to put any questions in the Q&A session as we are moving along, especially if you fall behind. If you let me know, we will try to make sure that everybody, if you are coding along with us, everybody is kind of with us when we are coding. So we'll give you that opportunity so that you can ask questions during the session. And my co-hosts Hannah and Sunil and Mani, they are all actually monitoring the chat as well as the Q&A sessions. So as soon as something comes up, they will definitely let me know, and we can stop and make sure that everybody's moving along with us. All right, so what's the agenda for today? So what I plan to talk about is a little bit about what is data science. And once we get a little bit of an idea of data science, we will see how does the ecosystem for data science and artificial intelligence look like. I'll talk a little bit about a data science approach that we use, and share that with you guys and see if that's something that maybe you guys can approach as well. After that, we will do a hands-on project. So the introduction, what is data science, this is going to take about 15-20 minutes of our time. And then we will get into the hands-on portion. So majority of the workshop is going to be hands-on, where you can follow along. The time duration that we have is about 4 hours. So what I am planning to do is I am actually going to give you guys maybe a 5 minute or a 10 minute break every hour. And we will try to wrap it up a little bit sooner. So instead of taking a break in the middle, I will give you guys some time back at the end of the presentation so that you can attend any other session that you are looking for. So I'll try to, we should be done by about 4:30, between 4 and 4:30, and you will have a little bit more time to actually go and attend some of other cool presentations that are going on. So that's the plan for today. And again, question and answer is not really for the end. You can ask them at the end as well, but you are welcome to ask them while we are moving along. All right, so what is data science? So this is the definition when you search data science on Wikipedia, that's what comes back. So it's an interdisciplinary field that uses scientific methods, processes, algorithms, systems to extract knowledge from data. Now the data can be structured versus unstructured. So I'm sure that most of you would be familiar with what is unstructured versus structured data. In this definition, there are a couple of key terms that I would like to highlight. So the first one was algorithms, and then there was basically systems and coding. So coding and programming is one of the fields within data science that you need if you want to get into this field. So if any of you are aspiring to be a data scientist, coding and programming is what is required as part of that. Algorithms, where math and statistics come in, are also one of the key elements or key components of data science that you need in order to be a data scientist. Last but not the least, business knowledge. So knowing the industry is very important in terms of understanding data. So for anybody to work and understand data, it is important that they know the business and they know the industry. Even if you are looking to go into something even marketing and sales time, there are terminologies that the sales and marketing people use. There's information, click rates, that kind of information that you get in your data, and if you're not familiar with that, it becomes difficult for you to understand that data. In addition to that, there is something that we will talk about a little bit as we move along, which is feature engineering, or creating new additional information or features within your data. And that becomes very difficult if you are not familiar with the industry, or if you're not familiar with the field. It becomes difficult for you to understand the data and create additional information or knowledge out of that data. So these are the three key components within the data science field, and anybody who is actually looking to get into this field, this is what is, we believe, required as a data scientist. So if you are looking to get into this field, these are the core skills. Of course, you need other things like being passionate about data, being able to look outside the box and have a logical thinking. All of those things are required. Be a good team player. All of those things are required. But these are what I like to call them as hard skills, that you do need these skills to be able to perform your job, to be able to do what is expected out of a data scientist. So this is what a modern day data scientist should have as a skill set. All right. So how does the ecosystem for data science, and these are some of the terminologies that you will hear big time. So artificial intelligence, data science, big data, data analytics, machine learning. What are those and how do they fit in the full ecosystem of data science? So hopefully this kind of visual explains that a little bit. So the overarching field is artificial intelligence. And within artificial intelligence, we have something which we call it as machine learning, in which we try to make the machines learn so that they can make some decisions. And within the field of machine learning, one of the techniques is deep learning. So there's a big hype about deep learning and neural networks. It is one of the techniques within machine learning that we use to make the machines learn and make decisions based on their learnings. So that's deep learning. Now, a lot of buzz in the industry right now is about big data. So big data is basically a lot of data, as the word kind of suggests. But in addition to being a lot of data, which in big data we call it as the volume of data, there are some other attributes of big data as well. There is velocity of data, there is variety of data, there is veracity of data. So big data has not only just volume, but it has other attributes that contribute or that make it big data. And that kind of is utilized by deep learning, machine learning, artificial intelligence. We utilize, like in all those fields, we do utilize data, and the data could be big data or even regular structured data, which comes in a database kind of a format. Now, data analytics is a part of data science, where again data science includes data analytics in it. So we do data analytics, and then we do predictive analytics, which is basically data science. So there is data analytics where we are looking at in the rearview mirror and see what has happened before, and then there is predictive analytics where we are trying to look into what is going to happen in the future. So those are kind of data analytics kind of comes under the umbrella of data science, and we look at both of those in order to kind of understand and drive knowledge and value out of the data. So that's a little bit about the ecosystem. And again, if you guys have any questions, feel free to put them in the chat or Q&A session, and I will try to get to those whenever they come along. All right. Next, I would like to kind of introduce a couple of people on my team, my colleagues. So this is a group that we have. Of course, this is just a couple of people from LearningFuze here. On the top left side, that's me, Zia. Then right under there is Tim. So he is one of the instructors at LearningFuze, and then we have TJ and Cass on our team as well. So a little bit of introduction of the LearningFuze team. All right, and then what LearningFuze offers is basically a data science program which is part-time, designed into two modules, module one for machine learning, module two for deep learning and AI. And both the modules are about 12 weeks long. And then if you take both of them together, there is a 3-week gap in between. Again, the modules are very hands-on, and there are multiple projects that you do. Again, the focus is on hands-on learning in the bootcamp. So that's a little bit about the program. Again, the program is offered part-time Monday, Tuesday, Thursday from 6 to 9:30, and then we have lab hours earlier in the day if people want to catch up on projects. So that's how the program is structured. All right, now moving along. So this is a little bit more about that, about the program, but let's talk about the project that what we are going to do today. So our project today is going to be pretty much all companies are looking for revenue. And even if you're a nonprofit, you're still looking for revenue because you need to generate revenue so that you can actually pay the people that are employed as well as help others also. So whenever companies are looking for revenue, they have marketing campaigns that they do. So this data set that I'm going to use is actually available through Kaggle. It's a retail bank data set from Portuguese, and it is about marketing campaign that were run for the bank by the bank so that they can acquire more customers. So our fields or our goal in this project is going to be that we will look at marketing campaigns data, and we will try to figure out, or we will try to see if we can predict by certain percentage or by certain probability that this person has a chance of becoming a customer. And we will try and see if we can build an algorithm that can do that for us. And once we are able to build the algorithm, we will see what the next step is, that how do you find out if your algorithm is good or not. So those are some of the steps that we are going to follow along. But again, going back to, it is basically the goal of the project is that using the data from marketing campaigns, are we able to build an algorithm that will tell us which person or which customer or which prospect has a higher chance of becoming a customer, and then the bank can focus on those people instead of actually focusing on everybody and then losing out on those people. So that is our goal today, is to actually build a model like that. To approach this project, or to approach this kind of a business scenario, and this is just an example for a bank. This could be any other organization. It could be a wireless provider. It could be a telecom company. It could be a healthcare organization. It could be any of those fields because everybody needs sales, and everybody has an outbound marketing team or that actually does the outbound outreach to prospects. Now, for any of these projects, this is one of the data science approaches that we take, and I'm going to share a little bit about that approach. So at the top of the approach is that we need to understand what we are trying to do. So in this case, our goal is to actually get information about from the data that we have, which is about marketing campaigns. Can we get information or enough information that we can actually build an algorithm that will be able to help us identify potential prospects from a list of data? So that's our goal. Again, the first step is data gathering. So we try to access data. We go to our database team, figure out or find out from them that, okay, in the last couple of years or last 5 years, what kind of campaigns have we run, and what were the results, who became a customer of ours versus who did not become a customer of ours. So we will actually gather data in that way. Once we have gathered the data, the first step is to actually analyze the data, look at the data, and try and see if we can find some patterns, some interesting stuff there. Once we have a better understanding of the data, we move to the third step, which is data preparation. So the data could be in many different formats, and you will see in the hands-on piece that when we have data, when we look at the data, that the data could be in multiple different formats. So we will prepare the data so that an algorithm can understand the data. And once we have prepped the data, we will pick an algorithm, train the algorithm, and come up with a model that does predictions on who has a higher chance of becoming a customer. Once we have built the model, or once we have trained the model, we are going to evaluate the model and find out what kind of results are we getting. And once we have the results, then we see that if we are able to, based on those results, if we are able to actually answer the question that the business wanted. And from there, we actually, once we are happy with that, we go to the implementation phase. So this is the process that we are going to follow along. And I will leave the slide up here so that we can be honest to it, and we can come back to it during our presentation. So I had earlier asked my co-hosts that if they can run a poll to see how many people are familiar with data science versus data science, machine learning, and somewhat Python. And my understanding is that most of you are familiar with it. So that's great. And I hopefully we will have less challenges in there. But again, if you get stuck at some place, if it's a syntax problem or something like that, please feel free to chat or put that question in the chat, and I will and the co-hosts will be able to look at the chat, and we'll try to help you out so that you can work along with that. All right, so now I am going to switch gears. And what I am going to do is I am actually going to start working with the data. So the first step in this process is, so I'm going to switch the tab now, and you can see I went to a Google tab. Hopefully you can see that. And in Google, please, if you're going to follow along, please search Google Colab. And once you search Google Colab, your first result should be Google Colab, and you can click on that Google Colab, click on Google Colab, and it will open up the Colab environment for you. It is a Google Collaboratory, which basically hosts a Jupyter notebook. And once you get here, I have multiple notebooks here. You may not have those, or you will probably not have any of the notebooks here. If you're new to Google Colab, just click on New Notebook, and it will actually open up a new notebook for you, which should look, it is coming. It should look something like this. Now, the next step is that you need data. So let me put the link in the, can I put it in the chat? Let's see, how difficult would that be? All right, I am actually going to put it in the chat. And if you guys go to this link, you will be able to actually download the data. And the data file, and once you have downloaded the data, we will upload the data here. But the data file is called, let me just see what is the name of the file. The name of the file is telemarketing data that you should see when you actually go to that site. So if I paste that link here, this is the site that you will get to. And once you go to the site, if you scroll a little bit down, download dataset. So if you click here on the download dataset, you should see the data, and then you should be able to download the data. So it's telemarketing data and then the one.csv. So this is the data, how it's going to look like, and you can download it from here. So I will give you guys maybe a minute to download that data. And then once you have the data, we will go back to this Google Colab environment and we will start coding. So I'm going to give you guys about a minute to actually download the data, save it on your machines, and then we will upload the data here to Google Colab. While you're doing that, we can actually name this project whatever. We can say intro to data science. And I need to spell it right. Intro to data science, and this will become the name of the notebook. Again, a Jupyter notebook is nothing but an IDE in which we can code. And in an IDE is basically a development environment where you write code, and it makes it a little bit easier by providing you help in terms of functionality, so that you can code a little bit faster. All right. Again, from here, once you have downloaded the data on your machine, we will come back to this Google Colab environment, and on this left-hand side here at the top, there is this icon. When you click on it, it actually asks you what file do you want to upload, and you pick the file that you have downloaded, and you click open, and it gives you a warning saying that this file will be deleted when this runtime is recycled. It's absolutely okay. You can just click OK, and the file will be uploaded here. So hopefully everybody is able to get to this point. Let me know if you guys have any challenges. Otherwise, we will start coding in the next minute or so. Again, on the left-hand side at the top, there's this icon. When you click on that, it gives you the ability to actually pick a file that you want to upload. So you're going to pick this file and upload that file. And once you upload the file will show up on the left-hand side of the screen. So I have a question saying that I do not see the downloadable file. Are you able to go to this site? And the link is in the chat here. If you go to this link, you see the download dataset here, and click on this download dataset, and this file will show up like this, and then you can download that from here. Let me know if you still have any challenges, but we will kind of start moving a little bit. And again, please let me know if you still run into challenges about downloading the file. All right, so we have uploaded this file here. Now, the first step that we want to do is, let's go back to the presentation. So the business goal we understand. So the business goal was now that we need to build an algorithm that will predict who has a potential of being a customer of ours. First step is data collection. So in this case today, I provided you the data. So we have the data which you have uploaded to the environment. The second step is that we need to analyze the data. So for us to analyze the data, the first thing is that we need to read that data into this notebook. And for reading the data in the notebook, what we need is a Python library called pandas. So I'm going to import pandas and this PD is just an alias. So alias meaning that kind of nickname. So we have given it a nickname so that whenever we want to refer to pandas, we will just say PD, and that will refer to pandas. The next step is that I want to read the data. So I'm going to do pd.read_CSV. And read_CSV is basically a built-in function within pandas that allows us to read data. So we are going to provide the name of the data file, which is telemarketing data. And there's a space, guys, in there if you are going to use the name as is. If you have a different name that you downloaded the file with, please use the different name, whatever you downloaded it as. If you downloaded the file as is, there is a space between data and the parentheses and 1. So please have that space in here. And then once you run this cell, this is the data set that I had shared, that you can see in this tab here also. So we have the data downloaded and uploaded into Google Colab, and now we have read it in the Jupyter Notebook. Now, this function helps us read the data, and what we are going to do is we are going to create an object, and we are going to call it data, and this object is what is going to store this information that we have here. So we are going to store it in this file, and then we run it. So the next code cell, we will just try and see if we can see the data. So if we call that object data, we can see the data now. So the data is available for us to have a quick look. Now, once we have the data in our notebook, the first step where we really want to start off with is we want a snapshot of our data. We want a high-level overview. We want a picture of what is in the data. So for us to get a snapshot of the data, we are going to go data.info. And info is a function that is built in that provides us a little bit, it provides us a snapshot and a little information about what is in the data. It gives us a high-level overview of that. So we have a total of 41,188 rows. We have 15 columns. These are our column names. So age, job, marital, education. These are our column names. This is how much of the data is non-null. Non-null meaning that this data is filled in. So 41,188 values are filled in. And if you look at this number and this number, because they both match, that kind of confirms that in the column age, we have nothing missing. So we have no missing values in this. And if we go down this row, or the column's name column, we see that it looks like that all of our data is filled in. So that's amazing. It very, very rarely happens in real life that you get data that has nothing missing. It happens, it almost never happens. But in this case, this data has already been cleaned and massaged. So the data that has been provided to you has been done, some data prep has been done on that data already. Anyway, so the data that we have is filled in and has no null values. Now, these are some of the features that I am going to very quickly go over. So age of the person that was reached out. Job is what kind of work or what kind of job they have. What's their marital status? Education. By default, what they mean is that has their credit been ever been in default? So that's something, the information that they have, that bank has, that has their credit ever been defaulted. So that column represents that information. And we'll look at the data a little bit in a couple of minutes once we get to that next cell. The next is housing. So housing information, if you look at that, like, do they own a house? Yes and no. So it tells us that if the person owns a house, yes, and if the person does not own a house, no. The third, the column right after that is loan. Again, it's yes and no, because do they have a loan versus do they not have a loan. Contact. So contact column here, we can see tells us that how they were contacted, what they called on their landline, and it looks like that the data is a little bit old. We used to have something called landlines. I'm sure that most of you are not familiar with what that means, but we used to have something called landline. So telephone means that they were landlines, and cellular, of course, is cell. Month means that which month were they approached, what they called last time. what day of the week were they called. So was it Monday? Was it Friday? Was it Tuesday? So we have information about when they were called. Duration is how long was the conversation. So last time when we called and we were able to talk to them, how long was the conversation? And then there was campaign. So how many campaigns have this person been a part of? Giving us an idea of, okay, like have we reached out to this person in 5 different campaigns versus one campaign? So campaign actually gives us that information. Previous P days so previous is a separate column. So P days basically means how many days ago what they called last time. So if we look at this column P days here, a lot of them are 999, which is 3 years, I guess. So these people have not been approached. Wherever the value is 999, they have not been approached in the last 3 years or so. Previous means that one was the previously, okay, let me just have a quick look. Outcome of the previous campaign. So what this means is that what happened in the last campaign. So did they talk to us? What was their opinion? That kind of an information in this previous column. And this last column, Y, actually tells us, did they become a customer of ours or not? So no means they did not become a customer of ours. Yes means that they did become a customer of ours. So we have in this Y column is the column where the data tells us that if they became a customer based on our previous campaign or not. In data science world, we actually call it the target field. This is the target feature because this is what we are trying to predict, or this is what we are going to try to predict. Hopefully everybody is able to kind of get an idea of what the data looks like. Now, in terms of this last column here, we have data types. So we have int64. So some of the fields are int64 and the other fields are object. So when you get data like this, you have to actually look at each and every column. What I am going to do is I am actually going to review a couple of columns with you guys, and then I will let you guys review the remaining of the columns at your own time, at your own pace. You can do it after the session. You can review other columns and see how it looks like. So what we will do is we will pick one column, which is an integer, and we will pick one column, which is an object. And we will try to see if we can get some more information about that data. So let's start off with the object column. So I am going to pick the column marital, and I want to understand what is in this column marital. Generally speaking, what I would think is that it would be information about somebody who's married. So if we scroll up a little bit, this is the marital column, and we see married. So I'm assuming that it has information like married versus unmarried. So let's see how we can do that. So again, we go back to our object, which is data, and within the object, we have this column marital or feature marital. We look at this feature marital, and we try to figure out what kind of unique values are there. So we do a built-in pandas function called nUnique, which is number of unique. And once we run this, it tells us that there are 4 unique values in this marital column. All right, I was thinking that it's going to be married versus unmarried. So 2, what are those 4? So if we want to figure that piece out, we can go one step further and we can go marital, again, the same feature, but instead of doing number of unique, which we did last time, we are going to do unique to actually find out what those unique values are. And these are the 4 unique values. So they have married, single, divorced, and unknown. So there's some people that we don't know if they were married or not. So these are the 4 unique values that we see in our data here. So this feature marital has these 4 unique values: married, single, divorced, and unknown. Gives us a little bit of an idea. if you want to go one step further, okay, you want to find out, okay, yeah, there are married and single and divorced. We want to see how many of these. So there are a total of 41,188 people. How many of these were married versus single versus divorced versus unknown? So how do we find that out? There are many different ways of doing it. Again, pandas has a built-in function for that also. Again, pandas makes your life very easy because it has a lot of functionality that's built in. So this marital, and then we are going to do value counts. And value counts is a built-in function within pandas that allows us to see how many, the frequency of each unique value. So when I run this marital value counts on this, it tells us that out of the 41,188 people, 24,928 are married, 11,568 are single, 4,612 are divorced, and 80 we had no information on. So this kind of gives us a little bit of an idea of the column or of the feature marital that we have in our data set. Similarly, when we the other columns that we have that are object, we have to look at those data and try to understand a little bit more about what do they have, and do they have many classes, do they have a couple of classes, and what kind of distribution is there within each class. So this is a little bit about understanding or finding out a little bit more about a marital column, which was an object. Now, the other type. So let's go back now and let's go to the other type. The other type is age. And age is the other column that we are going to take is age, and the age is an integer type of values. So integer means that it's a number. So when we have a number, generally speaking, what we try to figure out for numbers is that, okay, what is the mean, what is the median, what is the mode for those. So let's go to data, and we want to find out what is the average age, what is the median age or average age for this, or mean, which is basically average. What is the average age or mean age or the median age? So again, the feature is age. So we go data.age, and then we want to find out the mean. And mean gives us that, okay, the average age of this data set, of the people that are in this data set, is 40 years. So that's the average age. Now let's try to, or let's see what we can find out, or what's the median age. So again, we go back to our object data, we go to age, and we find out using this median built-in function that what is the median age. So the median age is 38 years, and the mean age is 40. So again, mean is average, median is the center point. So they are a little bit different, but they kind of represent how does the data, or what's the center point of that data. And the average age is 40 years in this group, and the median age is 38 in this group. This is how we can find out a little bit more about or for a numeric field that we have in our data set. So numeric versus object, or you can say numeric versus categorical, because in data types, we have numeric types of data and we have categorical types of data. And we have seen that the object types are the categorical types, and the int types are the integers are the numeric type of data. So we can basically take find out more about the numeric columns like this. However, there is a built-in function again in pandas which will give us an overall view of all numeric fields in the data. So what I want to do is I want to find out this mean median for all the numeric fields. And I don't want to go individually one by one. I want to find out for every numeric field. So I can go data, which is our object, and describe. What describe does is is it provides us descriptive statistics for that for all the numeric fields. So if you go back to the info, you will see that we have age, and then we have duration, campaign, P days, and previous as our numeric fields, and age is up here at the top. So it actually provides us information about age, duration, campaign, P days, and so all the numeric columns. And what it tells us is the count, which is how many, mean, which is the average. So the age average was 40.02, and there it is, 40.02. Standard deviation, so 10.42 standard deviation. Minimum, so the youngest person in our group is 17, whereas the oldest one is 98. So it tells us the range. Okay, this is your this is your minimum, this is your maximum. So we start from 17, so the youngest person is 17, and again the median, the center point is 38. So a center point is where 50% of the data is above and 50% of the data is below. So that's your median age, and it actually provides us information for all the numeric features here. And this this output of describe has a lot of good information. So what I'm going to do is I'm going to give you guys maybe a minute to actually look at this output, and also if somebody is actually a little bit behind, to maybe give them a time to catch up. So I'll give you guys a minute to look at that, and I would like to see if you guys can actually find something interesting in this data based on this output here. So let's see if we can find something interesting in this describe output. And in the meantime, if anybody is actually behind, please let me know in the chat, and we can try and ensure that everybody is caught up. So just giving you guys another 30 seconds to actually have a quick look, maybe find out. Okay, so there is in the chat, there is a message saying that you are behind. Can you tell us a little bit more about where you are at, or is there anything not working for you? While we wait for a reply, I am actually going to tell you a little bit more about what we see in this campaign. So this, if you look at this column campaign, you can see that this is, so we have maximum of 56 campaigns that we have run. Majority of the people were part of about 2 campaigns. 50% of the people, actually 75% of the people were either 3 campaigns or less. But then there are some people who have been a part of our database for a long time and have been a part of 56 campaigns. And then there are some people who have been previously approached 7 times. So this actually gives us a lot of good information about our data that is numeric. It tells us kind of statistical information about that data. So yeah, so there's a comment on there that P days are primarily 999. So how do you find that out? That what is the values in the P days? Again, we basically did data.pdays, and we can do value counts, and it will give us a little bit of an idea of what we have in P days. So 39,000 people have not been approached in the last 3 years, but then there are people who have been recently approached, like maybe 3 months, 3 months back, or 2 months back, or maybe even last month, these 26 people. So it gives us information about when were they, or how many days earlier were they approached last time. So you can actually get some good insights into your data using these methods that are built into Python. All right. So now, okay. So it's been almost 50 minutes that we have started. So what we are going to do is we are going to take a 5 minute break here. I am actually going to be here. So anybody who is behind, especially there is, I believe there is somebody who's a little bit behind. So it will give them a little bit of an opportunity to catch up. And if you are behind, if you please let me know where you are at. I can ensure that we can use this time to actually make sure that you are caught up on this. But for everybody else, we'll take a 5 minutes break, guys. Go grab some water, coffee, whatever, and we will get started at in 5 minutes. So at 1:55, I believe. All right. For anybody who is behind, can you please let me know that where you are at, so that we can the beginning of the code. Okay, beginning of the code. Are you talking about this? Okay, excellent. Hopefully you can catch up. Keep you guys give you a couple of minutes to catch up. Let me know when you have done this so that I can move forward, so that you can see the next code.
I think Jia, we lost your voice.
Can you hear me now?
Yes.
Okay, awesome. Okay, I have to unmute myself if I want to talk, right? Okay, moving along. So what we are going to do now is we are actually going to. So we did a little bit of an analytics of the data. We did try to figure out some information from the data and see if that will help us. But generally speaking, when you're looking at a lot of numbers, especially when you look at the numbers in this describe output here, most of them is a number, so there is a high probability that you can miss something, or you may not be able to pick it from here. So visualization is always a good idea. Visualization does help big time to actually make us understand or make us find different patterns within the data. So I am going to show you guys a couple of visualizations of how you basically can understand the data a little bit more. One of the things that in data science or in machine learning or in statistics you hear a lot about is that, is your data normally distributed or not? So here what we are going to do is we are going to try and see that if our data that we have in this, is that normally distributed or not. So let's pick the first column, age, and we want to figure out if the data is normally distributed or not. For us to actually get an idea of is the data normally distributed or not, the plot or the visual that we need to build or that helps us get an understanding of that is a histogram. So what we are going to do is we are going to import the library, first of all, that will help us do visualizations. So we are going to import matplotlib. Now matplotlib is a Python library that helps us for visualizations. Within that library, we are going to import a class called pyplot. And that has the built-in functions that we are looking for, and we are going to import it as PLT. And when we run this cell, this helps us import the file. Again, we insert a new coding cell right underneath. And for us to get an idea of if the data is normally distributed or not, we are going to actually use the first column here, age, and we're going to build a histogram that will give us an idea of if the data is normally distributed or not. So for histogram, very simple, from the matplotlib library, we are going to build a histogram, and we will pass the feature or the column or the data that we want to build histogram about. So data.age. Data.age is the feature that we wanted to find out about. And once we build the histogram, you can see that, well, there is a long tail on the right-hand side. So if you look at from a statistics point of view, this is not normally distributed. Is it close? Yeah, maybe it is close enough, but it is not normally distributed. Normal distribution should be more like have same kind of tails on both hand side, and so it's more like a bell curve. So you have tails, nice tails on the both sides, and then majority of the data is in the center. Here we have a long tail on the right hand side, and it goes up till 100, which kind of confirms the fact here. If you go up a little bit, that on the age, the maximum age is 98. So this library or the histogram is smart enough that it can actually figure that piece out and actually then cuts off the visualization at 100 because that's the largest value in there is 98. So this gives you a little bit of an idea of if it's normally distributed or not. We have this column p days also, so we can actually build a histogram for p days as well. So let's see how does p days look like. So plt.hist and then again data.p days, which is what are the previous days. So you can see it is very heavy on this side. So majority of the people were approached maybe about 1,000 days, or 999, I think is the value there. So 999 days ago. And then there are some people that were approached like kind of closer to 0 days, or very recently. So either we have approached majority of the people, either we have approached them about 3 years ago, or some people we have approached them in the last maybe a few days, because if this is 200, this is 100, so maybe in the last 3 months are the people that we have approached. So histogram kind of gives us a little bit of an idea of how the data is distributed within that feature. Now, the histogram is or can be done for each feature, or it can be done together for the whole data set. So we can actually build a histogram for the complete data set as well. And if we pass the complete data set, okay, so we have to pass it in a way that it is okay. The reason is because when I go back to the data, if I pass the whole data, it has these alphanumeric or categorical columns. So I cannot call these categorical columns. However, pandas can help us with that. And I can say data.hist. So because this object data is a pandas data frame, pandas also has a functionality where it actually uses matplotlib to build histograms. And because it's an object that that pandas understands the object, it can actually filter out all the columns that are object and build a histogram for you for only the one that are not objects. And you can see all of those. Now, this graph does not look very nice. So what you can do is you can actually pass a parameter in here, which is fixed size. And in the fixed size, you can actually enlarge the figure. So I can say 10 on the horizontal axis, 6 on the vertical axis. Can I build something like this? So this is a histogram. Again, when I was doing a histogram using matplotlib, straight calling the matplotlib library, and I was saying that call a histogram, it was giving me an exception because it is the library is unable to actually differentiate between objects and all that. So this was not working. However, because pandas, this object is a pandas object, I can actually call hist on this object. And because pandas can understand the difference between object and integers, it can actually just pass the integers and build that for you. Now, we do see this histogram, but it's still a little bit not laid out properly. So how can we make it a little bit nicer looking? So we can do plt.tight layout. Tight layout actually adjusts the layout and fits it to your size a little bit better, and it makes it the graphs a little bit more nicer. So this is how you can actually take your data frame and build a graph. I'm sorry, guys, it's a little bit loud here. I'm going to mute for one quick second. Sorry about that, guys. I don't know how loud was it on your end, but it was a little bit loud here. So I just wanted to kind of mute it for a quick second so that you guys don't have to hear that. All right. So this gives us a little bit of an ability to build a histogram, which is for all the data points that are numeric within our data, and the tight layout actually kind of puts it in a format which is nicer looking, and the columns are adjusted a little bit more. So tight layout, helps you with the layout of your figure. Now, just very quickly going back to this data point or the histogram for age, we did say that the age was not normally distributed. So plt.hist and then we go back to age. Uh, Now, this data is not normally distributed, or doesn't really look like normal distribution. It's close, but it's not. How do you make data normally distributed? What can you do to your data so that it kind of reflects a little bit more about normal distribution? So one of the techniques that you can use to make data normally distributed is actually take a log of that feature, of those values. The values that are in that feature, we will take a log of that. What a log does is that it actually compresses the larger values more and the smaller values a little bit less, so it kind of adjusts that a little bit. For us to actually use log, we need another library, which is NumPy. So I'm actually going to import NumPy as NP. So we're going to import the library NumPy as NP, and we are going to do a log of this feature. So I'm going to take a log of this feature, which is np.log. And when I run this, now this looks a little bit better than last that we built. So this, where is the other one? Okay, I use the same one. Okay, let me just do it here. So plt dot hist, and then we do data dot age. So you see, this one looks a little bit better than this one because it has less tails and kind of similar tails on both sides. There is another log functionality, which is log 1+. So let's try and see if we can do log 1+. And what it does is that it just adds 1 to it, because the log of 0, and we don't have any zeros, but the log of 0 is infinity. So in order for us to get around that, there is this log 1+. And when we do log 1+, this looks more normal or better than the other one. And now let me show you guys. It is np.log, and the other one was np.log1p. So this is how the log looks like. The bottom figure is the log, and this one is the log 1p. So the 1p does look a little bit better than the one that is just log. So again, you have to try and see what kind of transformation works best for your data. There are other transformations that you can do that might work a little bit better for you, but you just have to kind of get an idea of what transformation best works best for you, and all of that can be done by actually doing some kind of looking at the data and trying to understand that data, and building transformations based on that. So this is one way of looking at that, and this is one of the visualizations that we can do. The other visualization that a lot of times you want to understand is that, does my data have any outliers? And if I have outliers, how much or what is the amount of outliers that I have in the data that I have? So for us to get a little bit of an idea of outliers for one column, for one feature, what we can do is we can build a box plot. A box plot kind of tells us a little bit about what the what potentially what could be an outlier. So I'm going to use again from matplotlib, not mat but boxplot, and we will pass the feature again age. Again, we're using the same feature age, and we just want to kind of get an idea of, do we have, what kind of outliers or what kind of data do we have in this? So this is how a box plot looks like. So box plot gives us some good information. So this is our lower value. This bar or this line here, and the bottom line for this square here or the box here is the 25th percentile. The line in the center, which is kind of yellowish orange kind of line, that is the median. The top of this box is the 75th percentile of the data. And then these are called the whiskers. And anything above or below the whiskers are called outliers, or are statistical outliers. Now, how you define outliers, and that's a completely separate topic, and we can talk about that for a very long time. Um, but in this case, that is anything above the whiskers or below the whiskers are outliers. And we can see we have a few of these outliers here. And this whisker kind of is at the bottom end and the top end. But this is how um, you can see if you have outliers, and maybe you want to explore those outliers a little bit more, try to get a little bit more understanding of what kind of values are there in the data that are above 70 years of age. So if we wanted to pull something out and kind of get a little bit more analysis, we can go back to our data, and within the data we can say, okay, for age greater than 70, because we can see that in this um, we have outliers that, and this is kind of reflective of about 70. So what is above 70? So we can uh, we can get an idea of this by actually filtering the data for anybody who is older than 70 years of age. And when we run this, we get the results back, which is basically, this is the data frame that has only people that are above 70 years of age. And you can see here from the row count that you have 422 rows and 15 columns in this. One sec, guys. I'm sorry, I thought I did mute, but I don't know what happened. My apologies, guys, if I did not mute. All right. Okay, so this is this is the data that we have for people who are above 70 years of age. And if we wanted to analyze, okay, these are kind of our outliers or statistical outliers. Let's see what is going on here. So again, because we filtered it for anybody above 70, so you see that the age is primarily above 70 here. It's not going to be like everything is going to be above 70, but you can see only 10 rows here because a total of 422 rows. And you can look at that data however you want to slice it and dice it. But this is one of the ways of actually filtering the data and trying to just understand what the outliers are, and where you and what information can you find for those outliers. All right, so going back to our box plot. So this is our box plot that we did for one feature. Now let's try and see if we can build a box plot for all the features. So again, I am actually going to start off with the pandas object now, because again, if I pass this object in matplotlib, it gives an error because there are quite a few fields that are not numeric. However, if you do it using the pandas object, it actually is able to understand that. So I'm going to do data.boxplot, and this should build a box plot for us for all the features that are numeric. So again, 5 features, and again, this duration, because it has some very large values in that duration, the scale is very big. And you might have to individually look at these to figure that piece out. But you can see that there are outliers in duration also, which a lot of them are in that range above maybe 700 or 800. And these are the statistical outliers for the duration feature. So in this way, what you can do is you can basically graph anything that is um, that is numeric, and you wanted to kind of get an idea of the outliers. Now, in this case, again, we have all of them, and the scale is kind of um, basically disturbed by this duration. Can we do something to actually take the duration out? So let's try that. So we do go data dot drop, and we say, okay, can you drop duration from the data set? And then can you build a box plot for us? All right. We have to pass another parameter here. Access is equal to 1. And let's see how the box plot looks. So now the box plot looks a little bit better than what we had earlier, because we have taken those values out from here. But there are some values here still that have some bigger numbers, and that's kind of messing the graph out. So let's see which one has higher values. So let's go back here to our, where is the describe? So P days has 999. That is what is. So let's drop P days also, and see if we can have a nicer graph here. So I did drop duration, and now I want to drop P days also. So P days also dropped from there, and let's do a histogram. So both those columns, so now it looks a lot more better, and this is our age column, and we can see that this is the outliers, this is the outliers for campaigns, this is the outlier for previous. So in this way, matplotlib actually gives you a lot of flexibility into looking at some of these columns, and trying to build or trying to analyze the data a little bit more better. So you can actually kind of filter the data however way you want to filter, and build graphs based on that. So this is a little bit about box plots. Now I just wanted to kind of give you a little bit more. So we had this column earlier that actually I wanted to see if we can build it for P days, but we can build a box plot here just for P days. So I can actually go plt dot box plot, not box plot, and I can go data.pdays. This will give us a box plot for P days. And again, this is the $1,000 or $1,000 999 value that actually kind of draws everything down. So this is, you can see that those are definitely an outlier, and you should look at that and see what does that 999 represent. Is it really 3 years that we have not spoken to them? So they might be categorized in a different way. Again, some of those are basic information about looking at the data different ways. Now let's go back to our data, and this is our data frame. Now this data frame has a lot of columns, and earlier we looked at a way of finding out how many unique values were there in one column. So we were trying to figure out how many unique values were there in the marital column. Can we find that out for all the features or all the columns for this? So we can. And how we do it is we go data.nUnique was the function that we used earlier, and we are going to use the same function, and we are going to try and see if we can find out the unique values for each and every feature in our data set. And you can see we have age at 78 unique values. The target feature has 2 unique values, and duration has 1,544 unique values. The question that comes up now is, can we plot this to make it a little bit more visual for us so that we can see what it is in this? So let's try and see if we can visualize this to make it a little bit more visually understanding for us, so we can understand that. So let's try and see if we can build a plot for this. So I'm going to go, I need to start spelling it right. Data dot and unique, and again I'm going to use the pandas dot plot functionality, and we are going to do a plot like that. Okay, so it gives us some information from age. We go here, and then there is this spike at the duration. So it gives us information about the unique values or our data set. This looks okay. We get some information, but maybe what will be more interesting is that if we have it as a bar chart. So can we build a bar chart out of that? So we can pass a parameter called kind, and we can say bar, and this will give us a bar chart for us. All right, so this is a bar chart. Again, the duration is very big, and that's why we can't see anything else here. So let's do the same thing. Let's take the duration out so that we can get an idea of what is there. So I'm sure that you guys would be able to do it now. But so let's do drop, and we are going to drop duration from here, and the parameter, the other parameter that we have to pass is x, ASCII access is equal to 1. And this is how the unique values, so we have age has the most after duration in terms of unique values. And then if you just want to flip it around, you can, this is bar, you can actually go horizontal bar. So bar H will give you horizontal bars. And this is how your data looks like when you do it in horizontal bar. Again, just some of the techniques that will help you analyze the data and look at the data a little bit more visually, and hopefully that helps you get an idea of what is inside the data, getting some more information within the data. Now, going back to this data.pdays dot value counts. I think we did that earlier, and we were just trying to understand what is the frequency of basically these values that we have here. So what I want to do is I want to actually take this and build a graph based on this as well, just to analyze and see how do these stack up against each other. So what I'm going to do is, again, using the same functionality from pandas. So I'm going to do pdays dot value counts, and with value counts, I will actually try and see if I can plot this. So we do plot. And again, if I do not pass a parameter in there, it's going to build a line graph for us. And line graphs are nice, but sometimes may not be very informative. So let's do bar H so that it actually comes as horizontal bars. Okay, so these are the values here, but we are unable to get any information out of it. Because this 999 value is kind of very big, and it has a lot of information in there that or a lot of unique values or a lot of frequency. So it actually goes up to 40,000, and that's why everything else is very small. So can we actually do something so that we can take this 999 out and see if we can figure out the others in there? So how will we do that is basically taking this data and then data.pdays, and we are going to say less than 900. This is now a data set that has less than 900 days, and now we can see it a little bit more easier to see than that. Now again, if we want, we can actually pass a parameter here, which is fig size. And with fig size, we can actually give it vertical a little bit longer. So maybe 6 here and vertical 10. So hopefully, okay, it'll pressing this equals to sign here. Now we can see a little bit more that, okay, so 3 has the maximum frequency. So the maybe 3 months or 3 days. So this was P days. So it's number of days. So more after 999, the maximum frequency is 3. And you see how graphs can help us find this out a little bit easier than just by looking at numbers, because we were looking at the numbers here, but it was difficult to figure out which was the highest after that. Well, it is not very difficult. You can see it here also, but these actually make it a little bit more easier for you to find this piece out. So this is how you can use the matplotlib library from Python to actually analyze the data and try and see if you can find out some kind of information or some kind of some insight from your data, something that you can report back to your team, to your managers, and say that, okay, this is something I found in the data, and this is what is I believe going to be very helpful for our team. Okay, so we have kind of we've gone over histograms and box plots, and we've done a couple of other line graphs as well. There is one type of graph that actually you can build to find out relationship between two variables. So let's quickly go over that graph, and that is called a scatter plot. So I am actually going to build a scatter plot, and I just want to kind of get an idea of that, okay, is there a relationship between the age and the target variable, which is did they become a customer of ours or not? So how do we do, how can we build a scatter plot that will give us a little bit of an idea that if there's a relationship between age and if they're going to become a customer of ours or not? So plt.scatter, that's just like histogram, just like box plot. Scatter is the function that helps us build a scatter plot. And within our data, we want to go age. That's one of the features that we wanted to put in the scatter plot. And the other one is data.y. Y was our target feature that we had earlier. And if I scroll back up, you can see in our data set, this is the Y feature that I want to build. Oh, so Y is actually yes and no. So this is yes, this is no. And we can see that we have people who have become our customers starting from very young. So maybe 17 years old was the youngest person that was called out, and going up till as high as probably very close to 100. And same for no. So looking at this, it is very hard to actually see that if there is any relationship between age and between the age of the person and if they are going to become a customer of ours or not. So similarly, you can build other graphs to get an idea of if there is a relationship between that feature and the target. Let's pick one other feature real quick here, so that we kind of have a little bit of, we've done it a couple of times. So scatter. So we build another scatter plot, and we are going to do this time for data dot. Okay, let's do it for marital. Marital and data dot y. Again, y is our target feature, and we are just trying to get an idea of if there is any relationship that we can kind of figure out between them. Because this feature is again a categorical feature, and both of these features, so not just one, but earlier we had age as a numeric feature, and the other one was categorical. So this chart actually is not informative at all because it doesn't tell us anything, because we are just building, we're just trying to figure out that if there's a relationship between two categorical features, and this kind of scatter plot does not help with that. You might have to approach it with something this style, where you actually do some value counts and you try to figure out the frequency of those, and see if that frequency somehow affects the result of yes or no for that variable. So this was two categoricals, and let's very quickly let's see if I have two numeric features that I can pick, just to show you a histogram, oh sorry, a scatter plot between two numeric features. So let me just pick two. I'm going to go, I should not have done that. I could actually go back here. Okay, let's do it the right way. So I'm actually going to look at the data again. So data.info, and let's figure out what are, so we have age as a numeric feature. What else is numeric? Or duration. So let's see age and duration. Do they have any relationship? So we are going to do plt.scatter, and then this is data.age, comma, data.scatter. And we build a scatter, oh, not scatter, data.duration. So we build a scatter plot for these. So this is how a scatter plot for two numeric would look like, because both of these are numeric and continuous fields. So this is how the scatter plot looks like there. And again, it's difficult to figure out what kind of relationship these two variables have together. Maybe not very evident from this graph again. And that's why machine learning helps us, because it can, within the learning process, it can figure out things that we might miss building from this. All right, one last quick visualization so that you have a little bit of idea. There is something which is called a scatter matrix. What a scatter matrix is, that it actually builds a scatter plot between two features and does it pairwise for your data. So I am actually going to do a scatter matrix. Scatter matrix actually comes from pandas, and it is from pandas plotting. You can actually do a scatter matrix. And in the scatter matrix, you just pass your data, whatever your data is, and it will build a scatter matrix for you. Okay, it is building. Because the data, if your data is big, it might take a little while for it to build. So this is not a big data set. And again, you can see this is the scatter matrix. If you want to do a little bit of a bigger size, you can do fig size, and you can go 10, 6 maybe. And let's build a scatter plot. Again, depending on the data size, this can take a little while, but because we don't have very, the data is not very large, it's not. So again, if you look at this diagonally, these are histograms. So this is what is good about scatter matrix, is that diagonally they are histograms, and individual columns, they are all scatter plots between. So this is a scatter plot between duration and age. This is a scatter plot between age and campaign. So diagonally, this is a histogram of age and age, or this is a histogram of duration and duration. So diagonally we have histograms, whereas all other columns are scatter plots. So this is one other technique that you can use. So you can actually build a scatter matrix for your data set that will give you an idea of a scatter plot and a histogram, or a combination of a scatter plot and a histogram together. So this, and you can actually do plt dot tight fit on this as well, or tight layout on this as well, and this kind of lays out a little bit more nicer your graph. But again, it's the same information, it's just laid out a little bit more nicely. So you can see that now you don't have those bunch of values at the top, and the information is laid out a little bit more nicer this way. It's visually a little bit more pleasing. So this is a little bit about visualization and how you can look at your data and try and see if these kind of relationships or these kind of um, uh, you can find some more insight within your data. Okay, so let's go back to our presentation slide and see that we have analyzed the data. So we were doing some data analysis and we have analyzed the data a little bit. So our next step is data prep. So now we want to actually take our data and prep it in a way so that we can feed it to an algorithm. So this is our data. Let's go back and have a look at the data again. So this is our data, and we want to organize it in a way that this we can see what kind of prep we have to do to actually make the data fit the algorithm. So the first step in here is that we can use the numeric data. So the numeric data is age, then the duration, campaign, previous days, previous. These are our numeric data. So we can use the numeric data to build an algorithm. Now, can we use all of that? We can definitely use all of that. Or we can pick and choose which features we believe are going to be helpful. So one of the ways to find out which features are going to be helpful is actually by taking a correlation or trying to understand it, that what kind of relationship is there between the features. Now, when I look at the correlation, Pandas again gives us this feature called core, C-O-R-R, and using core, we can find out the correlation between the columns and the target. Now, in our case, we don't see the target Y here because Y is no and yes, and it is not a numeric feature. So the first step that we have to do is we have to convert that Y into a numeric feature. So I am going to actually convert the column Y into a numeric feature, which is 0 for no, 1 for yes. So I'm going to go take that column Y and convert it into a numeric feature. And how I will do it is I am going to use a function, which is a single line function called a lambda function. That lambda function will take the data that we have and convert that into a numeric versus non-numeric. So data dot, we are going to map over each and every value. Data dot y dot map. So all values are y, and we are going to do this lambda function, which is basically nothing but a function that is written in one line and can actually do a iterative loop for you. So it's a lambda function, and we are going to say that if the value, so 0, if the value is equal to no. And if the value is not no, then we want to make it 1. So this is how you write a lambda function, is that if the value inside this y is a no, you are going to you replace it with a 0. And if it is anything but a no, replace it with a 1. And let's actually, instead of doing this, let's first look at the data after we have done that so that we know what happened. Once we run this, you can now see that this Y column has converted into a 0 and 1. And these two were yes. So 41183 was a yes. And if I go here, 41183 is a 1. everything above was a no here, everything above is a no, everything above is a zero here. So this gives us the ability to actually, this using this lambda function, we are able to convert our target feature or our target variable y into zeros and ones. All right, so we have done that. Now let's look at the correlation. Let's try and see if we can find that out and see how they are related with the target. So this is our column target feature y, and these are our other features. So this column represents the relationship between those features um, and the other features. So we do see that duration has a high correlationship with with the target feature. So we are going to use this feature duration, and we're going to pick one more feature, and we just believe that age might be another good feature to pick, just to kind of figure out what kind of relationship we have. 1 second, guys. All right, can you hear me again now? Sorry about that.
Yep.
Okay, great. So now what we have done is we have figured out that for us, duration is one of the features that has a very high relationship or has a higher relationship with the target y. And we are going to pick duration, but let's pick one other feature, age. We just want to see how age is going to perform. And we are going to use these two features to actually build our model. This is again part of data prep. Picking the features, so selecting the features, or in data science, we call it feature selection, is a part of data prep. So what we did was we used correlation. We did some analytics earlier or analysis earlier, and we have picked up we did some correlation, and we have picked up two features that we are going to use in our algorithm. Now, first of all, how do you pick two features out of your data set? So this is your data, and for you to pick two features, you have to have two square brackets, not one, but two square brackets, and then you just pick the two features. So age, and then the second one is duration. I almost forgot what we picked. So these are the two features that we are going to use. Sorry, I'm going to mute it for 1 quick second. I apologize, guys. It's a little bit loud here. Some of the benefits or pleasures of working from home, but it's a little bit loud here, so sorry about that. All right, so this is how you can, from your data set, you can pick two features that you can use for your algorithm. So when I run this, I can see that from the data, I have picked up two features. Now, these two features are going to be the independent features in our data set. And I am going to represent those independent features by the variable x. And generally, in statistics, we see that x is representative of the independent features. Independent features are features that actually are going to be available to you so that you can find patterns in those features, and then you can make a conclusion or make an inference of what the result is going to be like. So the features that are going to be helping you make that inference are the independent features. So in our case, we are going to use these two independent features, age and duration, and we assign it to a variable name x. This is arbitrary, but I've just picked x as a value. And let's call that variable so that we can see how it kind of, once it has picked up those two features, what does the object x looks like. So this is how the object looks like, and it has 41,188 rows and 2 columns. So earlier we had multiple columns, but now what we have done is we have reduced it to 2 columns because we just wanted to see how this is going to perform for our algorithm. That was our first step. The second step is we want to pick the target feature. And the target feature is Y in our case. So we are going to still call it Y, but we are going to pick that feature Y from our data. So data, and then we are going to pick the feature Y from that data. And let's call that feature. And this is our variable Y. So we have the independent features here where we call them X that are going to help us make inference for these features in Y. So Y is our, okay, this is hypersensitive right now. Maybe it needs a break, I guess. So what I'm going to do is stop. Okay. We are going to, so what we have done so far is we have taken out 2 features as our independent features, and we are going to use Y as our target feature. And we have both those features now. Now, the next step that we have to do is we have to find out what algorithm are we going to use. So in our case, so there are many different algorithms that are available. What I am going to use is basically a decision tree. A decision tree is that it actually takes your data and does what is basically, it looks at a feature and sees if I can divide the data into 2 groups or multiple groups using a split method. And it will actually divide your data like that and build a tree. And once the tree is built, it will see if it can predict the right results or not, or it can infer the right results or not. So decision tree is one of the algorithms. You can also think of decision tree as like yes and no, if else, that kind of an algorithm. So it's a simple algorithm, but it is really good because it helps you, like it can actually break down the question very easily into small if and else statements. So we are going to use the decision tree algorithm and build this. So how do we get the actual algorithm? We get it from the library sklearn in Python. So there is a library called sklearn, which is the machine learning library of Python. Most of the algorithms for Python are available in sklearn. So we are going to use sklearn dot, and in this case, because it's a decision tree, so it's in the class tree. And we are going to import a decision tree classifier because we have 2 classes as a target variable, which is Y, which is 0 and 1. So we have 2 classes. So we are going to import this decision tree classifier. So this is the algorithm that we are going to use, decision tree classifier. It is pre-written. The algorithm is pre-written, but we have to train it so that we can build a model or train a model based on that algorithm. So the algorithm is decision tree classifier that we are going to use. Once we have the algorithm, we are going to instantiate that class of the algorithm or define the algorithm. So we are going to call it tree. And with tree, we are going to instantiate this class of classifier and say that this is our algorithm, decision tree classifier. So let's run this. And once we run this, we have this object tree, which is our classifier. In this object, what we are going to do is we are going to pass our independent variables, which is X, and our dependent variable Y, row by row. And we will tell the algorithm to learn that, okay, in the first row, and if I scroll up a little bit, okay, this is becoming a little bit more challenging than I want it to be. Okay, so in the first row, we have an age of 56 and a duration of 261. And we will tell the algorithm that based on that row, and the age of 56 and the duration of 261, the result is not a customer. And you can see the result here, 0, which is not a customer in the Y. So this is how we are going to feed the data to the algorithm, row by row, independent variables, and this is the result. Independent variables, and this is the result. And we will feed it to this algorithm tree. So let's do that. And how we feed it is, or how we train the algorithm is by doing a fit. And when we do a fit, it actually starts learning based on the independent variables, what is the result. And again, as I said, we are going to feed it row by row. So we are going to go X comma Y. And once we do X comma Y, it will take the X information and see what the result is. Next row, X information, what the result is. And based on that, it will learn. And once we run this cell, it runs and actually trains. Once we have trained the algorithm, the next step, so the algorithm was decision tree. We used our data to train the algorithm. And now this tree becomes a model, which is an algorithm, which is a trained algorithm. So we have used the algorithm and our data to build a model. And this is as simple as this. It's Python and Pandas and sklearn have made it very easy for us to build or train algorithms. So now we have a trained algorithm. Now let's go back to our slides and see where we are at in this process. So we have done data analysis, we have done data preparation, and we have done the modeling phase. We have built a model that actually is trained using our data and the decision tree algorithm. The next step is model evaluation. So we have built a model. Now we want to find out how good is the model, because our job is not done yet. We have built a model, but the next step is we need to find out if the model is good enough or is it not good enough. Now, how do you find out if the model is good or not? So how you find out is, what we can do is we have this data set, and on that data set we also have if they become a customer of ours or not. So why the target variable is our true values. So we have true values for all of our data set. What we can do is we can make predictions on the data and see and compare the true values and see how well do they match. So what we are going to do is we are going to make predictions on all of our data that we have. So we're going to use the predict method, and it will take the tree model and predict on our data X. And once we run this cell, these are the predictions. So these first 3 people are not going to be a customer, but there is this one customer 1. So that person is going to become a customer. So these are our predictions using the predict column. So what I want to do is I want to save these predictions into a variable which I'm going to call, you can see how creative I am with namings, is that I'm going to call it predictions. So we use the predict method to make predictions. How interesting. But these are our predictions, and let's call the predictions after that just to make sure that it actually saves. So we made the predictions on our X data set, and we stored them in this variable predictions. And if you compare the ones above and the below, they are the same. So it kind of tells us that this variable has all the information that we need. Now we have made predictions on the data. We also have the true values. What we want to do is we want to compare the true values and see how close or how correct or how accurate are we in our predictions. So what we are going to do is we are going to compare the two. Now, there are many different ways of comparing the two. You can actually manually write some functionality to actually test that out for you. However, I am actually going to show you something which is built in. And in sklearn, there is a method which is built in, which is called tree. Oh, sorry, tree. which is called score. So we are going to use our model and then score our model using this score functionality. And in the score, I am actually going to just pass the x values and the true values. The reason I am going to pass the x values is because it will automatically make these predictions on x and compare them with the y. And once it compares them with y, it will give us the result back, that what is the result. So when we run this, it tells us, so this actually tells us how accurate or how matching they were both. So it tells us that the result is 95% accurate. So 0.95 means that the algorithm is 95% accurate, which is pretty amazing. And we did very little work. So what do you guys think? Isn't this easy and simple? But there is something which is not, which we didn't do properly. And what did we not do properly? I know that I've been talking for a very long time. Here is a little bit of a chance for you guys to tell me in the chat, what did we not do properly, or why am I saying that this 95% may not be representative of how good the algorithm is? So here is a little bit of an opportunity. I would like you guys to tell me why we believe that this may not be representative of how good the algorithm is. So I'll give you guys a minute. Just put your comment. Why do you think that this is not representative of how good the algorithm is? And feel free to put it in the chat, or put it in the QA section, whichever. If you guys have an idea, let me know. Why is this? Why I believe, or why we believe that this is not representative of how good the algorithm is. Giving you guys a minute to kind of look at that and think about it, and maybe put your answer there. All right. Yeah. So the reason that this is not representative of how good the algorithm is, because we trained the algorithm on the same data and we tested on the same data. So we tested the algorithm on the same data that we trained on. And that is a big no-no in data science. We want to train the algorithm on training data and have a separate portion of the data that we will use to test the algorithm. So we need to separate our data between training data and testing data. And that is what we are going to do after the break here. So what we are going to do is we are going to take a 10 minutes break, guys. It's 3 o'clock now. So we will start at 3:10, and then we will go forward from here, and we will break our data into two portions: training data and testing data, and then train the model on the training data, and then compare the results with the true values on the testing data, and see how the algorithm is doing. All right. So for if anybody has any questions or anybody is behind, please let me know. Otherwise, see you guys in 10 minutes. All right. So welcome again, guys. And again, thank you for joining the session. I know that the weather is beautiful outside, so I am sure that you guys are kind of interested in data science, spending your Saturday afternoon with me here. But thanks for joining again. So we got a couple of questions during the chat. Hopefully, we were able to answer that. Yeah, so the next, we are going to move along and we are going to try and see if we can build this algorithm a little bit more better, or maybe make it a little bit more robust. So to recap, what we have done so far is that we have taken the data. So let's go back to our presentation slide, and let's see what we have done. So what we have done is we have collected the data, or we have taken the data. We have analyzed the data, got a little bit of an understanding. There's a lot more time spent on analysis and understanding, but we did a little bit of time on that. We have prepared the data. So we did some feature selection, manual feature selection. So we picked a couple of columns, age and duration. And we built a model, evaluated the model, and the model accuracy was really good, 95%. So sometimes when things are too good to be true, you start thinking that, okay, did I do something wrong? And then we looked at the process that we followed, and we figured out that, okay, maybe what we did was not the right approach, because we used the same data for testing as we used it for training. And the data that is for testing should not be used for training. So that's where we are at. And the score was 95% here, but again, with a little bit of a grain of salt, because the testing data was taken out from the training data. What we are going to now do is we are going to split the two data so that we have a separate training data and we have a separate testing data. How we are going to do that is basically, so here we are going to, I'm going to put a comment here, split data. And I'm just kind of making a note for myself here that after this, what we have done is we have split the data. So in splitting data, we want to split the training and the testing data. And in Python, in sklearn, we have a class called model selection. And within the model selection class, we have something called train test split. What this does is it actually takes your data and it actually splits it into two classes. Now, what we are going to, so first of all, we need to import this so that pandas can use this library. The first thing that we want to do is we are going to pass it two separate data sets. We are going to pass it X data set, and we are going to pass the Y data set. So we are going to pass it two data sets. So when we pass it two data sets, it's actually going to break both of them, X and Y, individually into two. So it's going to return us four data sets. So let's see how it works. So we do train test split. So this is the functionality that we imported here. So we are going to use that functionality here, and we are going to divide this into two. So we are going to divide this X data into two, and then we're going to divide Y data into two. And the one other thing that it requires, this functionality requires, is it wants us to tell us, or tell it, what portion of the data do we want to use for testing. So it wants us to specify the test size. And it's a number that you can pick. Generally, you can pick 10% for testing, 20% for testing, 30% for testing, 25% for testing. Let's pick 20%. Let's go with 20. And I am actually going to pass one other parameter here, which is random state. Random state is just so that if you guys are running it, yours and my result are going to be the same because of this key that I'm going to pass, and I'm going to fix the random state at 0. So the parameters that we have passed to this train test split is test size, We want the test size to be 20%, so 0.20. And then I just have passed a random state, which is 0. You can pass it whatever you like. But for you to have the same kind of results as I do, if you pass the same random state, we should have the same results. So we are going to kind of defining the key here. So this should return us 4 data sets back. Okay, invalid parameter random state. It's saying that it doesn't like that parameter random state because I did not spell it right. It is random, not random. Random state. So we can see it gives us 1 data which has 32,950 rows back. Then it gives us a data with 8,200. So this is the test data. And then it gives us 3950 again, which is the other training Y values, and then it gives us this. So it gives us 4 data sets back. Now let's take all the 4 values and we are going to assign those values to 4 different objects. So the first one is going to be xtrain. That's our X data set for training, or independent variables for training. This is our independent variables. X test is the independent variables for testing. Then we give it the Y, so target variable for training, and then we give it a target variable for testing. So this X is divided into xtrain and xtest. This Y is divided into ytrain and ytest. And we run this. So all those 4 are actually going to get assigned to these values, to these variables or objects. And what we are going to do is, after this, it's a really good practice to test out if they match. So let me show you what I mean when I say they match. So we check the shape of this one, and then we check the shape for this one. We check the shape for actually all of them just to make sure that they are matching in rows. Again, we have to feed the data row by row, right? So when we look at this, so xtrain has 32,950 rows. Ytrain, which is the target for xtrain, has 32,950. So it is matching. Xtest has 8238, ytest has 8238. So that's matching. So this kind of confirms to us that, okay, the data sets have been divided into training data and testing data. And now we have separate data sets. So whatever the result that we get is or should be the true results. So let's find that out. So let's define the algorithm. This time we are going to call it model, and we are going to use decision tree classifier again, and we are going to instantiate that class or initiate that class and define the algorithm decision tree classifier. This model now is exactly what we did here earlier. We did tree, and this time I named it different so that there is no confusion. So we built a model using this decision tree classifier and we fit it. Okay, so let's do the same thing here. So we are going to fit the model, but in this fit now, we are not going to use X and Y. What are we going to use? We are going to use xtrain and ytrain. So we are going to use xtrain, ytrain. So we're going to use xtrain and ytrain to train the algorithm. Again, what does fit do? It actually takes the data row by row and feeds it into the algorithm. And once it's fed to the algorithm then sees the correlations and then based on that learning, it actually tries to predict. So we run this and the algorithm is now trained. And because it's very small data set, the algorithm doesn't take very long to train. Sometimes the algorithms can take long time, like many hours or many days even to train, depending on how much data you have. So this model, which is a decision tree classifier trained on our data, is ready now, or is trained now. So what we are going to do is, again, as we did earlier, we are going to do model.score. And we are going to pass it the xtrain data and the xtest data. And let's see what is the score. Oh, sorry, xtrain and ytrain. And let's see what the score is when on our training data set. So you see, this is the training data set. This is the training target feature, and the result is 96%, even better than what we had earlier. So this is kind of good. But going back to the challenge that we had earlier, we used the same. So here we are actually testing on the same data that we used to training. Now we are going to do it differently. So we are going to test it on the test data. So we are going to score using X test and Y test. Let's see what the score comes back. Oh, so the score is 86% now. So it dropped by 10%, 10 points. Now this is true representation of your result, because you have trained it on a separate data set and you have tested on separate data set. So because they are separate data sets, this is a true representation of how good your model is. Okay, so 86 is okay, it's not too bad, but we want it to be a little bit more better. So what can we do to make the algorithm a little bit more better? So we can go back to our data set and we can see that if we can use any other column here. So we had a few columns and we have only used data and where is duration? And duration. So we have only used 2 columns here. But what we want to do now is we want to maybe add another column here that might help the algorithm be a little bit more better. So you have seen me do numeric data. So I am not going to add another numeric column. I'm actually going to add an object column so that I can show you how you can handle objects. So let's pick this marital column. And what I'm going to do is I'm actually going to use this marital column in the data now and see if I can improve the results. All right, so let's see what we can do. So I'm going to add here and say we are going to try to improve results for testing data. So that is what we are going to try and do. We are going to try to improve results for testing data. And how we are going to do is we are going to define again the variable name we want to keep, or I'm going to keep it the same. I'm very creative, so naming is no problem. And then I am going to use age and duration as we used earlier, because we did see that we were able to get about 86% results there. So we want to improve that. And to improve that, I am going to add another column here. And that was marital. Now this, I've added that. And let's look at this data now and see how it looks like. So in this case, this data is alphanumeric. It is married. And if we look at this a little bit further, we will see that x.marital unique. If we look at those, there are 4 different values in this: married, single, divorced, and unknown. Now, computers cannot handle alphanumeric data. So we have to convert this into ones and zeros. Now, there are multiple ways of doing that. I am actually going to do one of the simplest ones, which is basically called one-hot encoding. So what I'm going to do is I'm actually going to take this marital column and convert it into 4 columns: married, single, divorced, and unknown, and just do zeros and ones for those columns. So how do we do that? Very simple. Pandas gives us this ability to do get dummies and we want to pass the data which is X in there. So this data set we pass in this get dummies function within pandas, and what it does is it actually creates one hot encoding for us. So you see marital divorced, marital married, marital single, marital unknown. So what it does is it takes the unique values and creates separate columns for them, and wherever the value is there, it puts a 1. For every other, it puts a 0. So what we have done is we have taken that column, we have created what is called one hot encoding. So this is what we have done. Now we take this data, and I am actually going to save it into a new variable, which is X underscore, and I'm going to call it dummies because this data has dummy values in it. Again, independent features X using the dummies variables. And doing this, let's look at the X dummies and just ensure that the result is the same. So that was exactly what we were saying earlier, 4 columns, and we have age and duration. So what we have done is we have added another column, another feature to our data set, and we have kind of one hot encoded that feature. Okay, now this is our independent features, and again our dependent is Y, because dependent is already in zeros and ones, so we don't have to do anything for dependent. So dependent is zeros and ones. Now what's the next step? Because we changed the data, we have to do that split again. We have to divide it into train and test again so that we can use that. So I am actually going to take this subset, this cell from here, and copy paste it to make my life a little easy. And in this case, we are going to train test split the data that we have from this this dummies, and we are going to use that data. So instead of X, we are going to use X dummies. Again, the Y remains the same because Y we didn't do anything, but for X we have increased these columns, and this data set is called X dummies now, and it's not X anymore. So I've changed that here, and I have these columns here. Now, just to show you what it looks like, so this is how X train would look like. I've just picked one of them, and I'm going to just show you that so that you get an idea of what it looks like. So this is how X train looks like. This is the training data. This is the independent features. And you have age, duration, and then the 4 columns for marital. And we have a total of 32,950 rows and 6 columns. If we look at X test, that will have the remaining rows, which is 8,238, and again, the 6 columns. And the Y is divided exactly the same as X was divided. So now what we have done is we have split the data into training and testing, but we are using what is called as dummy variables in that, and we have added a feature added a new feature called marital so that it can help our algorithm build that. Now we go back to our decision tree. So we are going to call it this one model dot using the dummies variable, and we will instantiate the class again, decision tree classifier. And this will actually create a new object for us, which is called model dummies, which is again the algorithm decision tree classifier into that object. We have instantiated a class. The next step is we need to train this algorithm. So we are going to use model.dummies, and then for training, as we did last time, we are going to do fit. Now in this we are going to use X train and Y train because this is what our data looks like, X train and Y train. So let's do it again. So X train, comma, Y train, and we train the algorithm. So this is our algorithm that we have trained with model dummies. This is the algorithm with our X train data and Y train data. So What did we do after once we have trained the algorithm earlier? We took that algorithm and we tried to see what was the training accuracy of the algorithm, and then we tested it on the testing accuracy. So let's first find out the training accuracy. So model.dummies is our model, which is trained on our data and the decision tree classifier algorithm. And we are going to do, sorry, not predict. We are going to do score. And using the score, we are going to pass it xtrain and ytrain. And 97%. So earlier, the result was, I believe, 96%. Where is it? Yeah, here. So earlier, when we did xtrain and ytrain, the training data result was 96%. Okay, so this one improved. So it looks like that adding that that feature helped our model be a little bit better. So instead of 96, it's 97 now. All right. So now let's test how did the testing side of it did. So we are going to pass the X test, and we are going to pass the Y test here to compare. And fingers crossed. What did I? Oh, dot score. Too excited to see the result, right? Okay, so this is how the score, and it is 86.16 again. That is interesting. So it did not improve. So what is going on here? It was 86.58 earlier. Let's see what it is now. Oh, 86.12. So it actually got worse. So we added a new feature and the algorithm got a little bit worse. That is not what we were expecting. We were hoping that the new feature would add some more values to it. Okay, this may not have worked, but why don't we try something else? Let's try and add another feature to it. This time, let's go back to the data set. Actually, we don't have to go back that far up. Let's do data here and see what do we have in our data set. Okay, so let's pick another categorical column, job. So age and job should be important because it's what do you do. But we have not looked at job at all. So what kind of values are there in job? So let's do job dot unique, just to have a little bit of a perspective of what we are doing. Also, these are the unique values in job. So housemaid, services, admin, unemployed, self-employed, unknown, entrepreneurs, students. We have technicians, we have admin people, we have retired people. So we have different classes of jobs that we have. Okay, so let's add this to our data and see if this will help our algorithm a little bit more better. Okay, so we are going to do the exact same process again. So I'm actually going to do that. Okay, so duration, and then we had marital. And then now we just want to add job to it. This is our X data, and we're looking at this X data. You can see that this is jobs that has been added to the X. What did we do after that? We actually converted these object features into numeric features by doing one hot encoding, and the functionality that we used was get dummies. So we are going to use this get dummies functionality, and based on this get dummies functionality, what we are going to do is we are going to build this, convert these categorical features into zeros and ones. So let's see how that goes. So it is called X, and let's see what the result looks like. So we are going to convert these features into categorical. So we have marital, which were 4. So unknown, single, married, divorced. And then after that, we have job as admin, job blue collar, job entrepreneur. So what it did was it actually took all the job features and converted them into one hot encoding also. So very powerful feature, get dummies. It actually works really well, and it takes your categorical data and creates one hot encoding. Now, earlier we had, I think, 6 columns. When we did get dummies last time, we had 6 columns. Now, if we look at the features after that, we have 18 columns. So our data has grown substantially. So hopefully this helps. So what we are going to do is we are going to again look at the name this. So we're going to call it X dummies, and we're going to assign the value of this to this variable X dummies and create this object, and then let's look at X dummies and see how it looks like. This is X dummies. Again, 18 columns, 41,188 rows, and we have divided the job column into multiple columns by doing one hot encoding on the job columns. The next step after this, so this is our independent features, and again, we didn't do anything on the dependent or the target feature, which is Y. So Y remains exactly the same. What we need to do next? What is our next step after that? Again, we have redefined our independent features, so we need to redivide or do the split again, because we need to separate the training data from the testing data. So let's do that split again. So we are going to do train underscore test split. Again, the data is called X underscore dummies for our independent, and Y is the dependent. We want to keep the test size as equals to 0.20, and the random state equals to 0. So exactly same features. Oh, I forgot to assign it back to those X train. So I'm going to assign this back to X train, comma X test, comma Y train, comma Y test. Those assigned back to those, and let's run this. Because we had 18 columns, let's just make sure that we have the data proper. So let's look at X train real quick and make sure that we have the right data. So we have 18 columns. We can see here 32,950 rows, exactly the same rows that we had, and we have all columns one hot encoding. So everything is numeric. We don't have any alphanumeric in there. So the algorithm can handle that. Now,
we have a couple of questions.
Oh, sorry. Yeah, go ahead. David had a question. Is it hot encoding or hard encoding? It is one hot encoding. Let me type it out for you. One hot encoding. Is one hot encoding. Okay, so hopefully that answers that. The second question is better off, would we be better test result if we increase the training size? That's true. The more data that you have, the better result. The opportunity of getting better result is better with the more data. However, you want to keep significant data for testing as well. You don't want to go maybe 5% is a little bit too small. Because 5%, there could be a random chance that you do poorly or random chance that you do well. I can change the data, absolutely. 15% is, I think, still okay. If it did, even 10% is okay, and we can do that a little bit later. But let's first finish this and see what this does, and then I can change it one quick time, and we will see what kind of results we get by changing that. So thanks. Thanks for pointing those out. I was actually too busy trying to make this algorithm a little bit better. But yeah, please feel free to ask any questions that you have. All right, so moving along. So what we want to do, where are we at? So we looked at the X train. It looks good. We have 32,000 rows and 18 columns, and that's what we were expecting. Now what we want to do is, again, we want to redefine our algorithm. So this time, last time we called it model. So creative naming, we are going to call it model 1 underscore dummies, because again, we are using dummies in this, right? Again, doesn't have to have that name. I'm just naming it like that, just for me to kind of get back and easily understand that. So we create this new variable, and we instantiate the class again, decision tree classifier, and we create that algorithm and save it into this, or we define that algorithm and save into this model 1 dummies. Okay, so once we have done that, the next step after that is model 1 dummies, and then we need to fit. And what do we need to fit on? The X training data, or the training data, which is for independent variables, and then the training data for dependent. And we feed it to the algorithm, and we cross our fingers that hopefully the results are going to be good. So algorithm trains. Once the algorithm is trained, now you know the drill. So we go to model1.dummies, and then we score. And we score on xtrain first, just to see how the training went. So xtrain, comma, ytrain. And let's see what the result. Oh, 99%, almost 100%. That's pretty good. We are there. We can build an algorithm that's almost 100% true. And let's see how the testing does. Hopefully, fingers crossed. Model.dummies.score, and we do x test, comma, y test. Let's see how the result is. 84%. So the more variables that we are adding, the worse it is becoming. It's going in the reverse direction. It's not going in the direction that we want it to go, but it's going in the direction, in the opposite direction. We are adding more features, and it's becoming worse. So why don't you guys think about it for a minute or two, and maybe come up with what is happening here? Can somebody maybe put it in the chat? Let's see. What do you think that we are adding more features, and we're trying to help the algorithm, and it is not improving? I will give you guys a minute to think about this, and maybe if you have any thoughts, put it in chat, and let's discuss about that. Yeah. While you guys are thinking about it, give me 1 second. Let me just close these blinds. The sun is coming straight. All right, I am back. All right, any thoughts, guys? What do you think? All right, so let me give you guys a little bit of a hint. So what is happening is our algorithm is learning too much. It is learning to a point where it is actually memorizing the training data. And when it memorizes the training data, it is unable to do well on the testing data, because it has memorized what the training data looks like. And when something different comes, it is unable to do well on that. Now, there was a question, or there was a suggestion earlier that why don't we increase the size of the training data? So let's do that for 1 quick second, just to kind of see what happens. So I am actually going to copy this, and we are going to paste it here. And we are going to reduce the testing size. So I am going to reduce it to maybe 10%. We can go to 15%, we can go 10%. But let's go to 10%. So we increase the training data and we reduced the testing data. Now let's run it. Okay, because we changed those, so let's look at the shapes again. So this is xtrain dot shape, and then xtest dot shape, and then ytrain dot shape, just to make sure that everything is good. Ytest dot shape, and let's look at that. So the training data now increased from earlier, it was 32,000 rows. Let's go back up there. Let's see, make sure that where is the number of rows? Where did I not ever check it? Yeah, there. So 32,950 rows. So now the rows have definitely increased. It has gone up to 37,000. So the data has increased. Let's see what it does. So we are going to name it the same. Model 1.dummies, and we are going to first define the algorithm. So we're going to say decision tree classifier, redefine it. Now let's dummies dot fit, and what we want to fit on is xtrain, comma ytrain. And we fit the algorithm, and now because the algorithm is trained on this new data 37,000, let's see what the accuracy looks like. So model1.dummies, because that's what we used. Yes, model1.dummies, and we are going to score for xtrain, comma ytrain. And let's see how the score comes back. 99.20. Earlier it was 99.27. So close enough, but really, really good. But let's see what happens to the testing piece, because that's more important, because that's the unseen data. Score, and we go xtest, comma ytest. 84.68. 84.99. So it actually got a little bit more worse. And again, going back to the same thought process that I was talking about earlier, the algorithm actually trains so well on the training data that it actually almost memorizes it. And because it has memorized the training data, it is unable to do better on the testing data. This problem happens very commonly in data science. This is called over-learning. So the algorithm overtrains or overlearns. And when it overlearns, it is unable to perform good on testing data. So what can we do what can we do to make the learning a little bit less? So there is a suggestion. I'm looking at the chat again. So there is a suggestion that what will happen if we reduce it? Okay, so let's reduce the training size. So earlier we were 20%. Let's go to 30%. To do this, so we redefined it. Now the rows should go below 32,000. So let's redo it. So it's like 28,000. So it's less. We create the model again. So I am actually rerunning the cells again, but this should retrain the model. And then now let's look at the accuracy again. So the accuracy went down from 0.997, I think it was earlier, to 993. So a little bit training accuracy. So 99% still. Very good. The other one actually went up a little bit, 0.84. Again, reducing the size of the training did make it a little bit, maybe tiny bit, little bit better. but it's not really doing what we want it to do. And what we want to do is we want the algorithm to not train so much, not overlearn, and we want to keep the learning or reduce the learning of the algorithm, so reduce the training of the algorithm. So now I'm going to put a comment here, and I'm going to say that what we are going to try to do is we are going to try and let's try to try reduce learning. How do you reduce learning? The algorithm that we are using is a decision tree algorithm. And again, decision tree actually builds a tree, as I was talking about earlier. It actually does if and else statements and actually builds a tree. What one of the things that we can do is we can say, do not build the full tree. Let's build half a tree. And let's see what happens when we build half a tree. Okay, so now I am actually going to try and see if I can build half a tree. So the first step that I have to do is yeah, let's go back to the 20% because that's more like a reference for us. We have a few runs that we have done with 20%. So I'm going to go back to the training data of 20%. And just to make sure that the computer did what we wanted it to do. So this is the X-train data set after the split with 20% is 32,950, and this is exactly what we were looking at. And this is 18 columns now, and 18 columns was the 18 columns was the one where we saw the worst of the accuracy. So we have this 18 columns in the train, so that means that everything is good here. So let's build the algorithm. So this time we are going to call it tree with reduced learning, so RL. So we are going to reduce the learning, and we do the decision tree classifier here. But I am actually going to tell the classifier, do not build full tree. I just want smaller trees. And how do I pass that to the algorithm is I'm going to say maximum depth, my friend, tree for you is only 3. I do not want you to build the full tree. I just want you to do 3 if and else statements. Once you're done with 3, forget about it. Move on to the next one. All right, so let's run this. And we ran this. So this new algorithm tree reduced learning is kind of not trained, is kind of set up now. So we are going to train it. So we are going to do fit, and we are going to do x underscore dummies. I believe that's the right data set. What have we been using earlier? X. Oh, we are using X-train. My bad. Not X dummies. You see how quickly I can forget? Okay, so we are going to use X-train, comma, Y-train. And we are going to fit this algorithm. So this is the algorithm now, reduced learning that we have fit. So let's see how well it is trained. So X-tree reduced learning. And let's see how the training side did. X-train, comma, Y-train. All right, let's see. Okay, so the training score went from 99% to 89%. So what we were trying to do, we were able to get to that by reducing the depth of the tree. So we said cut off the tree at 3 branches. And we were able to reduce it. That was our goal, that we wanted to reduce the training so that it doesn't learn too much. Now, here is the big question. Did it do well on the testing? let's see. Let's find out. So, okay, we have to score first. Score. Now we are going to do X test, comma, Y test. Fingers crossed. Oh, wow. 89.9%. So if we go back up, the accuracy that we were getting for testing was 84%. So we were able to increase the accuracy of the algorithm on the test data set, which is where it really counts because it's new data that the algorithm had not seen before, and we went up. We actually are performing a little bit better than even on the training, how we are performing on the training data set. But it's very close enough. So by reducing the learning of the algorithm, we were able to remove overlearning, and we were able to help the algorithm predict better on the test data doing this. Now, this is where we say that in data science that the algorithm is now general. It can a generalized algorithm is an algorithm that can perform well on training data as well as it can perform well on testing data. And one of the ways for decision tree that I've shown you today here is by doing maximum depth of the tree. Let's quickly do one more example, and let's see if we can use a different feature to actually also reduce the learning. So
Jia, sorry to interrupt.
No problem.
There's one question from Jessica in question and answer window.
Oh, sorry.
So do you want to address it now? Yeah.
Yeah. Let me go there. Give me 1 sec. All right. So the question is that why don't we use all columns? And can we use all columns? I guess is a more general question. So we definitely can use all columns. The risk, again, as we were seeing earlier, was as we were increasing columns, we were starting to overfit. And you mentioned overfit in your question as well. So yes, overfitting is a major concern in data science. And that's why we try to make sure that we do not overfit. And by adding all or using all columns, there is a high risk that we will overfit. Again, it doesn't mean that you cannot do it. And again, it doesn't mean that this approach is right or that approach is right. You have to try and see how it performs, how the algorithm performs. But again, the key aspect in not using all the features is that the chances of overfitting or overlearning are very high if you use all the columns. Hopefully that answers. If not, Jessica, please let me know, and I'll try to get into more details. The other part of your question was, when do we stop? So we stop when we get good enough results that are okay for the business. So we go back to this presentation. So once we look at what we have done is we did modeling, and now we have done some model evaluation. Once we have done model evaluation and we feel like that, okay, we have a decent model now, we actually go back to the business and say, okay, this is the model. And at that point, we evaluate it with the business goal. Is the business okay? And if I go back to this here, we have an error of about 10%. So we are 90% accurate. So 90% of the times we'll be okay. 10% of the times we'll be wrong. Is the business okay? So we're going back to the business goal. Is the business okay with 10% wrong? And if the business says that, yeah, 10% is okay, you are good. But if the business says, no, we need more. And this is a sales and marketing example. And so sales and marketing, 90%, I think they'll be ecstatic. They'll be really happy Yeah, if you can reduce my time and my effort, and 90% of the times it's going to give me good results, I think sales is going to be really happy. But let's take that same 90% and let's apply it in healthcare. That 90% may not pass the business goal evaluation, because you are going to be wrong 10% of the times on human lives. That is not going to be acceptable with business. So there's no real hard and fast number that you can assign that, oh, 90% is okay or 95 is okay, because in healthcare you might need 99%. If you work in finance, your bank might require 95%, or they may say we need more than 95% because we do not want to lose money. Because when we are giving out loans, we want to ensure that all the loans are paid back to us. So again, depending on which industry you work with, this business goal evaluation kind of tells you when to stop, when it is okay to actually go there. And the business can actually, at a later point, maybe relax it a little bit and say, no, we are okay if you're 85%, or no, we need a little bit more because we have less bandwidth and we need a little bit more better model. So increase it from 89 or 90%. Let's go to 95%. Let's try to build something which is even better than that. Again, at some, you can never have a 100% model. Like in data science, 100%, that never happens. But you can get into 90s, and that's usually okay with that. Now there are other techniques to actually ensure that you do not miss any person that may have cancer. So there are other techniques to cover those, but a 100% accurate algorithm is not possible in data science, because again, we are trying to predict the future. Hopefully that answers your question. But if you have anything further, please feel free to kind of put it in chat or Q&A, and I'll be happy to take those. All right. So going back to this, we did use this feature maximum depth to reduce the learning. Now this was one of the options. Another option could be that we can use another feature which is called maximum features. So I am actually going to create a new instance of this class, RL2. And in this, I am not going to use maximum depth of the tree, but I am going to use maximum features. Maximum features is how many features at one time are you going to use? And I can say, let's take maximum features to be 3 as well. And again, 3 is an arbitrary number that I'm using. These are called hyperparameters. And hyperparameters, there is a science to it and there is an art to it. It's more art because you just have to see where the algorithm performs better. So we are going to use this maximum feature parameter and say that, okay, at one point, just use maximum of 3 features. Let's build the algorithm. So the algorithm is defined. And the next step is we are going to train the algorithm. Okay, so we do fit, and then we do xtrain, ytrain. We fit the algorithm, and then we try to predict. And let's go again with first the prediction on the training set. So we do xtrain, ytrain, and let go. I did not put score. Dot score. So let's put xtrain dot ytrain, and we put maximum features, and it went back up to 99%. Okay, let's see how it did with that. X dot score, and now we want to do x test, y test. And let's see how this performance. Oh, this reduced. So the maximum features that you use, maximum of 3 features at a time, is not helping us reduce the learning. How about we use both of them, maximum depth and maximum feature, and see if both of them together would help. So we will add that feature. So let me just copy this from here, bring it here, and we add the maximum depth feature here. So we put a comma here, and then we go maximum depth. And let's try both of them together and see what will happen when we have both the features together. And then we do tree underscore rl2 and then we are going to do fit again, x train, comma y train. We do the fit, and then let's test it out on the training first. Score x train, comma y train. See the score, 88. Okay, so earlier when we just had maximum depth, the training score was 89%. So this reduced the training a little bit more. Let's see if that helps increase the accuracy of the testing a little bit more also. RL2 dot score, and we are going to do it on X test, comma Y test. And let's see what the score comes back for that. 89.1. What was it earlier? 89.9. Okay, so it didn't really help the algorithm much, but it's close enough. So in this case, this is close enough to the earlier. So from that, what I gain is that this maximum features is not, in this situation, is not helping us reduce learning. Now, there are other things that you can do to reduce learning, but I think this is what I wanted to cover today, because this is, I believe, already a lot of information that I have thrown your way. So I hope you can see that from this approach, that first of all, we followed this approach and we built a model, and we went to the model evaluation, then business goal evaluation, and then if the business goal evaluation passes, we send it for implementation. But before we go there, you can see that this is an iterative approach. You do something, you train the algorithm, you see how it is doing. You do something else, you train the algorithm, you see how it is doing. And this is the iterative approach of data sciences, that you have to kind of go over and see how your algorithm performs under different conditions, you can say. When you change a parameter or when you change your data, how does it perform by how it is affected by one change versus the other change. So that's kind of the high level approach that you take in terms of data sciences, that it's an iterative approach, and you try to make it learn based on different parameters and ensuring that the algorithm is not overlearning, and on the other side, it's not underlearning. So guys, this is what I kind of wanted to cover today. We are at about 4:10, so we have a little bit of time. If you guys have any questions, I will be happy to answer any questions for you. Let me see if there's anything on the PowerPoint. No, so this is just about the course on LearningFuze, and this is the LearningFuze program that they offer. And I do believe that their next upcoming session is coming up on October 4th, and it's basically an introduction to data science offering that they offer. All right, anyways, I am going to now open it up for any questions and answers. So if you guys have any questions, please feel free to put them in the chat or in the Q&A section. I will be happy to answer them for you. Thank you, Bren. And if you guys have no other questions, I and hosts, if that's okay, I will like to give them back a little bit of their time so that they can attend some other cool sessions on DataCon LA.
Sounds great. All right then. Well, if there are no other questions, thank you, Zia, for your tutorial, and to the attendees for their questions and interactions during the session. You can contact the speaker directly if there are any further questions regarding this. And please provide your feedback using the form that will be provided in the chat box. And thank you again, everyone, for joining today's tutorial. Thank you to my co-hosts as well. And have a wonderful day. Thank you for being part of this year's DataCon LA, everyone.
Thank you guys for joining the session. I appreciate that. Thank you. Have a great rest of the evening and the DataCon LA.
All right.
Bye, guys.
Everyone.